Very good evening, guys. Am I audible? Badam, Shrikant, Shref, Ibrahim, Samson, Sam. Okay, people are still joining. Shai am I audible?
Yes, audible.
Okay, thank you. Okay. Let me-
Yeah, good evening, everybody.
Good evening, Shai All good?
Yeah, all good. Yeah. Mr. Deepak, what's happened? Your any close relative? He's passed away.
Yes. It was a very close relative that passed away, and I just heard about within 5 to 8 minutes ago before the class. So
Uh-huh.
it was supposed to rush because only at such times the people are required. Else anybody can manage, but not at such times. So now the things are fine. The last rites has been done, and the regular processes of the rituals which were supposed to be done are happening.
Okay, we wish God lead to him to the paradise, and he'll be in the peaceful.
Yes, thank you. Okay, fine. I think 11 people have joined. by the time I share the screen.
Yeah, Mr. Deepak, I have again the same complaint. We
Yes.
cannot do the practice without this recording, because like mathematics, physics, science, okay, we know and we can do the practice. But this we are now, the session which we are going now about the machine learning, really first time we are studying all this matter. So we
Yes,
need
yes.
this your recording, so we can do the practice.
So Saiji hasn't been given you recording for the past coding exercises.
No. Only I think might be only just 2-3 recording we got it.
Okay.
But the recent recording for this machine learning, we don't have it. Even the earlier recording also we don't.
I think Athira will help you out. Athira, are you here?
Yes, Deepak ji, actually there was some issues with our systems. We are upgrading our systems. So soon that all the videos will be uploaded in the YouTube. So you don't get worried. Every videos will be shared soon, very soon.
At least give them a deadline, Athira ji. At least they will be. Means,
Before the next class, all the videos will be uploaded.
is it okay,
Thank you,
Saiji?
Athira. Yeah, thank you. Thank you very much.
Fine. So I think any doubt in linear regression? If you have any doubt, let me handle it. Else we can move ahead. Okay, what was your key?
Yeah, please.
Yes, Saiji.
Yeah, please move ahead. But
okay, thank you. What was the key takeaway from linear regression, Saiji? Linear regression key takeaway.
Means the linear regression key takeaway. This suppose some we predict some dependent variable with the value of the independent variable.
Okay, like
all
of you can answer.
Like we can take the example of the flow. If the if the velocity increase, the flow will increase.
Okay.
Same we can take the example of the force. If the acceleration increase, the force will increase.
Fine.
So force is means the dependent variable on mass and acceleration.
Fine. This is the
actually m is the constant here, but the a is the
independent variable.
Independent variable. Yes.
Okay. Thank you. Is this concept understood by all? Is anybody having any doubt? Whatever Mr. Saiji has told. Anybody is here who is quite new, who did not have any classes before of linear regression and coding? Else they will say, I am the first one, I don't know. Fine. See, as correctly said Saiji, but linear regression, see, linear and regression means regression always deals in associationship. Associationship. Associationship means relationship. Relation. So any relation to between a independent variable and a dependent variable indicates associationship. If I write y is proportional to x square, is it linear or no? Give me an answer.
It is linear, yes.
Okay, you are saying it is linear. Anybody else in the we are around 15, 16. Anybody? Sachin, Balakrishnan, Anthony, Nalin, Abhilash Bachchan, Jitandar, Yashwant, Shan, AJ. Anybody who is pretty sure that whether it is dependent, linear or not linear? I'm talking about y is proportional to x square.
It is linear, sir.
Okay, Balakrishna ji is saying it is linear. Okay.
It is a polynomial. I think it's a polynomial regression equation.
let's draw how does it looks like Saiji first. है ना? When I write y is equal to x square, it means the power raised to the y is 1, but the power raised to the x is 2. First thing.
Yes, yes.
Whenever we have any either dependent or independent, either of the variable having the power raised to the power 1 only, till that process only, we call it a linear. But sooner, either y or x has power, means raised to the power order of magnitude other than 1. Mind it, other than 1. Other than 1 means it could be 2, it could be 3, it could be -2, it could be half, it could be 1/4, it could be minus half. Are you getting? These are the powers.
Yes.
So whenever the power raised to the power of variable could be y or x, in that situation, it is non-linear, my dear, non-linear. Why? Let me show it to you graphically. Say you had a y equal to mx plus c. It was a graph of like this. Yes.
Mr. Deepak,
Yes.
I think one of the class you taught us this ax square plus bx plus c, which is the quadratic equation. It is also is the regression.
That is a regression, Saiji, but not linear.
Okay, understood.
See, because having such things in mind is damn necessary while learning the machine learning. Because say if you even give a say if I change a color, suppose if you give a different set of equation to let your model trained over a set of data, say set of data is x1, x2, x3 and y. If you give this is a certain set of data and you give a wrong information to the data set, say y equal to, as you said, ax square plus bx plus c, and that's why you see you quadratic equation, and quadratic equation having a graphical representation in the form of like this, isn't it, Saiji? This is called parabola. When we had y square equal to x, this is also a parabola, but then this parabola would be around x-axis, symmetrical to x-axis. Similarly, if this is equal to y square is equal to minus x, then this take a form of this.
X minus minus direction of the x.
Yes. Say if I show it to you here, let me introduce you with a different website. Should I? You will enjoy playing with maths.
Yes,
Sure.
yes.
Never say no. Okay. We call it Dasmos. See, say if you draw 2x plus 3y plus 7 equals to 0. See, what is this line? This is line.
Yes, yes, yes.
But sooner I make it, say if I give a different square, say if I give just y is equals to x multiplied by x. See, what is it?
Parabola.
Parabola. If I make y equal to x square plus 2, say it is shifted to y-axis, means at x equal to 0, y is 2, and from y is equal to 2, the parabola goes like this. So similarly, you
Yes,
can
sir.
also add it -2 such that it goes down. You can give any number. So what is why I have given you such a thing? Like if I make it 2x square plus 3x plus, or if I give -3, then also it is a parabola only. But it is a quadratic equation. and we never call it a linear. We always call it non-linear. Fine.
Fine.
So whenever you are in doubt, whenever, always try to give a big shot in this Desmos kind of thing, like whether am I correct or should I recorrect myself. Say suppose here only, if I give a third picture to you, if I ask y is equal to say 3x x x 3x cube, I have written 3x cube. So x cube is taking such a form. See, x cube is taking such a form. If I give it to -4, so देखो, it shifted down. If I give it to uh, plus 2x square, say it has taken a parabola, a bit of parabola, -2, the same figure is shifted down. So whatever equation do you have, put it over here and see the nature. Then you will find anything which is having higher orders of x or y is not a linear, means it is not separating the things with a boundary having a single line. Fine. Am I audible and understood?
Yes, yes, clear.
Oh, somebody is saying
Yes,
I
you are.
missed last one. Thank you, thank you. So I think this, let me copy it to you such that you can make a good note of it. Where is that? 1 second. Chat. Okay, to meeting group chat to, I think meeting group chat is the same thing. Yes. Control V. This is the link. Are you able to click it? Just press it over.
Yes, yes.
Oh, thank you. So I think this is a, does anybody knew about this link that you can even imagine whatever you type in a maths?
No, no, no.
So
You
it,
don't know before.
okay, so it means it is a value addition to you today.
Yes.
Okay,
Yes,
thank
yes.
you. Let's resume. So here also we are doing the same thing. So when we goes for linear regression, we always check if y is directly proportional to x. If it is yes, we call it linear. If it is no, we call it non-linear. That's it. As simple as that. Nothing to remember, nothing to cram, nothing. Keep the life simple. Then only you would be able to make most out of it. And as far as today's topic is concerned, we call it logistic regression. Logistic regression. Don't worry, I'll let you understand today what is logistic regression. Then only the coding part help you. Because I understand that jumping directly into the coding is no longer a solution to you. You must understand the fundamentals. Coding could be understand knowing the fundamentals. If you don't know the fundamental, coding is just a piece of line which you just nod with me and later forget. Okay, logistic regression says it is again a regression, means again certain relationships are there, but this is not linear, this is logistic. Logistic says it has at least two values, as an output, So what do I mean by that? Suppose I had y equal to beta naught plus beta 1 x1 plus beta 2 x2 and beta n xn. In this situation, if I ask you what is the range of x here, x varies from which position to which value to which value?
Not to end.
No, sir. See once again. X is having 1 to n, means that is x1, x2. I am asking the value.
Okay, okay. One to n.
No, this is the notification IG. X1 is a
Mhm.
notification. I am saying the value of X, like 1, 2, -3, -7, 274 value. What is the range of the value where X can lie? Any idea? Okay, if I show you here, what is the range of value X is lying? Say, suppose if I close it, and I only make it the thing. So what is the range of X you can see? -10 to +10. See, -10 to +10. Okay, this is X, this is X, this is Y.
Yes, yes, yes.
So may I say this line is going to infinity in x-axis plus minus x-axis, and this line is going to -infinity to plus x-axis. We cannot see it, but it is going to infinitely long.
Yes.
Yes. Has everybody understood this? Because say if I
Yes,
write,
yes.
because say if I write y is equal to 2x, and if I write a value of x is 2777742, suppose big value of x. So when you multiply by 2, you get y. It means
Yes.
similarly, it varies in positive and negative direction both. Hence, we call that x has a range of -infinity to +infinity. Fine? Is this understood?
Yes, sir.
Yes, I understand.
Yes. So -infinity to +infinity, you can vary your scale and check whether my output comes where. So, but the output is lying. The output is lying in such a zone. In case of logistic regression, if I clear this, I think this is the eraser. Okay, yes. Your output is lying in such a zone such that logistic regression, it means you have an desired output of either 0 or 1. This is the desired output. Machine takes a desired output of either 0, means either there is something which is asked, or there is something which is not being asked. Suppose if I say whether okay, if I show you this, what do you see here? Cat or dog?
Dog.
We see both.
Left
There
side
are
is cat.
yes, there are both. So, and if I just hide this CNN dog, you can only see cat here.
Yes.
Yes.
So, like similarly, the machine also identify whether the thing is cat, dog, or say whether whether there's a human, non-human, whether there's a pen or pencil. Are you getting classification? Classifying
Yes.
the things. Yes,
Okay.
no, true, false. So the desired output is either 0 or 1. 0 means the thing is not there, means you call for the time being it's false, what is being asked, and 1 means true. Suppose I'm just taking it for the sake of understanding only, although it doesn't mean. So if something is asked, so the desired output of a logistic regression is this. Then you have to convert this particular equation into a logistic regression. So any idea that how would you convert? And mind it also, here the y-axis is also having a range of -infinity to +infinity, because if x-axis is varying from minus to infinity to +infinity, y shall also vary from minus to +infinity, because it's a
Yes,
straight
yes.
line.
Correct.
But now, when our logistic regression is concerned, sir, we are required to find the output between 0 and 1, or must I say 0 and 1 only. Then if I directly compare them, y is equal to such thing, shall it suffice right hand equal to left hand side?
Yes.
Yes, it should be.
See what I am asking. What I asked, your right hand side no doubt is -infinity to +infinity. Previously,
Yes.
your left hand side was also -infinity to +infinity, but now your desired output is 0 to 1. So don't you think that this must be equal, then only we can put equality sign, algebraic equation. We can only
Correct.
put equal sign when their
Yes,
ranges are
yes,
same.
correct.
Fine.
Yes.
So now is the time, sir. Now is the time when you redefine your y. When we redefine our y, we say, can we, okay, in your experience, in a mathematics, what should I write? The answer vary between 0 and 1. What is that one thing in maths which does not have a value greater than 1?
Inequality.
Gyani ji, no, inequality is not the answer. I can make it greater than 2 and less than 2. See here, let me answer your question. Say if I make it greater than 0, sorry, greater than 0. See, inequality is giving me a different. And say if I write greater than 1, inequality has changed. Okay?
Okay.
Okay. Now again, rethink. In mathematics, what is that one thing which never goes out of 1, on which always lies between 0 and 1? You knew it. Ask your best friend, Chat GPT, ask. See what answer does it she gives. Have you ever heard about probability?
Yes,
Yeah.
I have heard. Yes, yes.
Now understood? It has a value either 0, means it is just a what can you say, chance of occurring, whether something shall occur, whether something do not occur.
Probability P. Yeah.
Yes, P. Somebody remembers P. Good.
P.
P. Yes. So if you have a probability of event occurring P, then probability of event not occurring is 1 minus P.
Yes.
Fine. Suppose if I put P is equal to beta naught plus beta 1x kind of thing. Does it suffice? Here we have minus infinity to plus infinity. Here we have 0 to 1, not equal. I cannot say
No.
it is not equal. No. Again, we have to rethink what should be done. Let's check. Now, if I divide it, if I divide P by 1 minus P, means probability of occurring an event and probability of not occurring an event. Then can anything happen? Keep your values between 0 to 1 and see where does this ratio goes. Keep the value P equal to 0. What is the output of this ratio? 0 upon 1 minus 0. Answer is 0.
0.
Yes.
Now P equal to 1. 1 upon 1 minus 1. 1 by 0 is infinity.
Infinity, yes.
So now the range varies between 0 to infinity.
Yes.
Fine.
Yes.
Now we can see, Ranjit ji, we can say we have come closer to our answer, but not exact to the answer. Now we have to make this 0 minus infinity. Yes or no? Only this much is to be done.
Yes, yes, right.
Now, suppose if I make this P over 1 minus P, like if I just, 1 second, rub it. If I make this P over 1 minus P inside the log, if I take the logarithmic of P into 1 minus P, now put P equal to 0. P equal to 0 means log 0. What is log 0?
Infinity.
See, check.
Log 0, 1.
Log
No,
10
sorry,
is,
log 10 is log 10 is equal to 1.
yes, check log 0. Okay, let us see here.
Log 0 is undefined.
Log 0 is undefined. Undefined. See, log 0 is undefined. Means you can take it to certain direction. Let's give it to. So undefined means again you get infinity.
Infinity.
But again, if you read P equal to 1, P equal to means again log of 1 over 1 minus 1. This is log of 1 by 0. 1 by 0 means infinity. What is log of infinity?
Log infinity, I
Log
believe, I think.
infinity is infinity. It is infinity.
It is infinity,
Ah.
very, very long. It goes on and on and on.
Yes.
We forget really, we forget.
No worries, sir. Let me show it. If it gives you the answer, let me check here. If I give it to log x, see, log x is such a graph. And see, ध्यान से देखिए. See here, when the input to the log is 0, mind it, the log of output of the log is going towards minus infinity. Can you see?
Yes, yes.
Yes.
And when the input to the log is plus infinity, it is going up somewhere. See,
Positive plus side.
plus side. So
Plus side, yes.
log of 0 is minus infinity, whereby log of infinity is infinity, that we have already seen. So here log of 0 goes minus infinity. So can we say now that now we have range of left hand side as minus infinity to plus infinity?
Yes.
So
Yes.
can we now equate our log p over 1 minus p to this equation beta naught plus beta 1x?
Yeah.
Yes.
Yes.
I'm creating the analogy to it. Nobody will create such an analogy unless until well defined in one's goal, because people usually give you an answer like this. Let's see how do you get answers. You get answers. Okay, you have logistic regression. Logistic regression. Your output is between 0 to 1, and this is the output. It looks like this is the output it looks like, although this is a different output, but the real output will looks like this. Say here you have, okay, let me remove this output because this is a different output. We call it tan h. It is not the sigmoid. This is the output we have, say 0 and 1, and the output is between wherever it goes. The output never goes out of this. Okay, this is the output. Let's see how. Log of p over 1 minus p is equals to beta naught plus beta 1x 1 plus beta 2x2 and so on. I'm just constraining myself here. So mind it, whenever such things happen, you have to convert the output into certain form that machine can understand. Now minus infinity to plus infinity is equal to minus infinity to plus infinity. Now is the time to manipulate your answers. How to manipulate? This is log base e. Log base e, do you remember that you can write log a to the base b is equal to x? So you can write it as a is equal to b raised to the power x. Do you know it?
Yeah.
Okay, thank you. So similarly, how to write it? P over 1 minus p is equal to e raised to the power. If I write beta naught beta 1x equal to z, if I give it a single variable z, so may I write e raised to the power z?
Yes.
Yes.
Yes, thank you. So similarly, rearrange this in a format that you get answer between p and e raised to the power z. If I just reverse both of them, what happens? See, 1 minus p over p equal to 1 over e raised to the power z. And if I again solve it, it becomes 1 over p minus 1 equal to e raised to the power minus z. 1 goes this side, this becomes 1 by p is equal to 1 plus e raised to the power minus z, and take the reciprocal both the side, it becomes p is equal to 1 over 1 plus e raised to the power minus z. Understood?
Yeah.
Yes. So now we got an answer. If I change the background and color, we got p is equal to 1 over 1 plus e raised to the power minus z. This is the exact thing that logistic regression deals in. Here, if you put the values, if you change the values of what is Z, if you change the values of beta naught, beta 1, beta 2, and so on, as many betas, then this value varies and you get the different probability. You can put any value to this, you won't get the answer greater than 1. Should we check it?
Yes.
Yes, yes.
Yes. So
Yeah,
let's
yes.
write it 1
Plus.
plus
Always
1 plus
over a bigger number.
exponential raised to the power, say, minus 2. Answer आया. Now take the inverse of it. You have to take 1 upon 1 divided by, what should I write? Okay, let me copy it. Control X, Control V. See, answer.
Always 0 point something.
Now change the
Always.
values inside it. Minus 34, maximum 1. 34.3333. Not going greater than 1. Now, if you change the value of, say, minus 4.98, if you are changing the value of 2, 3, 4, 8, 7, 7, 4, 4, 9, 9, 1, 2, 1, 3, 4. See, not going greater than 1. Fine.
Yes.
Now, if I draw, if I put 2, then also it is not going. Say 2, 1, 3, 7. Okay, not greater than 1. It is going below 1. See, it is going below 1, 10 raised to the power minus 10, but not greater than 1. So say if I put X over here, X, it is giving the graph like this. But if I make it to minus X, can you see the graph?
Yes.
So what should I say? That such a graph is called, sir, sigmoid graph. Sigmoid means, what does it say? It says irrespective of what is the value the beta naught, beta 1, beta 2 or X is having, it won't go, the output will not go greater than 1. Can you see here? This is 1.
Yes.
So output will not go 1 irrespective of the input. And if the output, if the input is lesser than 0, the output is eventually going lesser than 1. Are you getting it? Fine.
Yes. Yes.
Yes. So such a function is called sigmoid function. Such a function is called sigmoid function. If I make a note for you here, this function, if I draw it, will be called as sigmoid function to you. And we define it like this. We define it sigmoid. P is equal to, or we, in a literature, we can find sigma z. Sigma z is equal to 1 over 1 plus e raised to the power minus z. Have you learnt it before?
No, we did not learn this.
Okay, thank you. So interesting. Can you see the mathematics? How the math?
This is very interesting.
How the mathematics started from linear regression and the same equation turned out to be logistic regression. So only the difference is that what do you want in the output and what should I call? See here, your desire was 0, 1 means only 0 or 1, either yes or no. But this output here, this is not given only 0 and 1, because see here, it is giving multiple values. Y here, y is 0.5, here y is 1, here y is something else. So here the output is between 0 and 1. Mind it. 0, 0.2, 0.33, 0.87, likewise. Now, your responsibility is to create an AND gate. Now, I think all of you know the AND gate. AND gate, pata hai? AND gate, do you know, all of you?
Yeah.
Yeah, where we have two inputs, x1, x2, and truth table as an output y. So it is 0, 0, 0, 1, 1, 0, 1, 1.
1.
Here, we already knew, you already knew that the answer is 0 here. Answer is 0. Answer is 0. And here only the answer is 1. That's it.
1.
Because it's an AND gate. This is y actual. Y actual means which we know that it happens. Now it is your responsibility to find what is y predicted, y hat. Y predicted. We call y hat as predicted answer, predicted value by the machine, predicted by machine. So what the machine predicts? Can anybody give me a hint that how to calculate y hat here? Sai ji, anybody? Ranjit ji?
I think it will combine x1, x2, and the y.
Okay. Some answer has come. Can you give me an answer regarding what do you understand by that, whether should we apply logistic regression or linear regression here? Because answer is either 0 or 1. Yes or no? So
Yes.
you have to classify whether the answer is correct or not correct, whether the bulb will glow or not glow. Similarly, so in such situation, we go for classification process. And for a classification, what we have just learned, sir, what is the process we just learned?
Logistic.
Probability.
Logistic regression. Logistic regression.
Yeah.
Logistic.
Logistic regression. And in the logistic regression, we have seen that your P was equals to 1 over 1 plus e raised to the power minus of
Minus Z.
z. Yes. Now this P is actually the output between 0 to 1. Can you see? Between 0 to 1. So
Yes.
try to label your probabilities. Try to label your output that my output is between 0 to 1. So in our logistic regression, what is that output end? So output at end is P. So we can call it y is equal to y hat. Sorry, P equal to y hat. And keep your input in Z and find the output. So can you keep your input here 0, 0? So it becomes for 0, this becomes 1 over 1 plus e raised to the power minus 0. Okay.
Yes.
X1, x2 all. But here you have to give beta naught. You have to give certain value of beta naught. Why? Because if you don't give that value of beta naught, e raised to the power 0 becomes 1. E raised to the power 0 becomes 1. 1 over 1 plus 1 becomes 1 by 2. And answer comes 0.5. Okay.
Which will be wrong.
So take your beta naught any value. Beta naught any value. Say take a beta naught 1 for the time being. Put this here. So it will be calculated as 1 over 1 plus e raised to the power minus of 1, that is beta naught, plus beta 1 x. Beta 1 x means x is 0. So answer is 0. 0 multiplied by any beta is 0. Plus beta 2. See, with x1 we have beta 1. With x2 we have beta 2. I think now you can correlate from your past classes of linear regression. So 0 into again 0. So again you are left with 1 over 1 plus e raised to the power minus 1. If you check here at Desmos, it will give you 1 over e raised to the power minus 1. What is the output, sir? check here. It is given as 0.73. So should I write 0.73 there? Do you understand what I am doing?
No, Mr. Deepak, this one, can you again explain that beta 1, beta naught?
Okay. See, if you remember, we had z equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on. Here we had
Yes,
only two features, sir. Just two features.
X1 and X2.
So only we will have two coefficient, beta 1 and beta 2.
No, in this table, X1 0, then 1, and then 1.
Yes.
Right? So
Yes.
so beta naught, okay, 0, then beta 1 again 0, right?
Beta 1 is not 0, sir. But whatever is multiplied with 0 becomes 0. This I said. There is certain beta 1, but it is getting multiplied with input, and input is 0.
Okay.
Then the answer becoming 0. See, if I take it to a different scenario, see. Say for x1, x2 with one answer, 0, 0. Calculate z, first of all. Calculate z. Z is calculated by beta naught plus beta 1 x1 plus beta 2 x2. Understood?
Yes.
Here, beta naught is given a value 1, which is fixed. That is intercept. That where the
Yes.
that will what should I call? Interact with y-axis. So beta naught is given a fixed value of 1. It will be always kept irrespective of the input. Then
Okay.
what is the value of x1 here? Here, see,
0.
0. So I'll write beta 1 into 0 plus
0.
beta 2 into 0. What is the output now?
1.
1. This is what I said. So now I have put y hat equals to 1 over 1 plus e raised to the power minus z, and z is 1. So minus 1.
Yes.
So same thing I have written here, e raised to the power minus 1, and answer is
Now
0.7.
Now understand, now clear.
Okay, thank you. So now your here, this answer has become, y hat now has become 0.73. 0.73. Similarly, your next answer will become, this is 1 now, mind it, this is 1.
Yes.
So now you have to put it 1 plus 1, 2.
Correct.
0.88. So your next answer is 0.88. This will also become 0.88 because
0.88. Yes.
and 1 is, again you have to do it, both are 1. So both are 1 means 1, 1, 1, 3. If I make it to 3, 0.95, maximum 0.95 means 95% probability is 0.95. See, still, why I am doing this for you is, you can check that when you had, no, one minute, this was 1, this was 0, and beta naught was giving a value of 1. Okay, I have taken beta naught 1, that's why this answer is coming like this. No worries. You can change it as per your suitability. So here this is saying that your y hat, the prediction is 73%, 0.73. Here the prediction is 0.88, 0.88, 0.95. So how to remember the logistic regression, or how to read it? It says, if it is 0.5, if the output is greater than 0.5, if the output is greater than 0.5, consider it for a different class. If the output is less than 0.5, consider a different class. See, this is what I mean. If the output is greater than 0.5, consider a class. And if the output is less than 0.5, consider a different class. Are you getting what I am drawing?
Yes.
Say, like if the output is 0.4, consider it as a cat. But if output is 0.65, consider it as not cat. It could be something else, but not cat. Not cat. So this is how this probability 0.5 is a threshold. So this 0.5 value will serve as a threshold, sir. That how the machine understand that whether should I give it a label of cat or something else. So if the probability of the input or whatever calculation has happened comes greater than 0.5, it will assign the label not cat. If it is giving a probability of less than 0.5 or 0.5, it will give it a cat. That is why this is called classification problem. It serves for classification problem. And especially in the classification, we call it binary classification. How many classes are being identified? 2, 3, or 4?
Binary.
How many? 2. Yes. How many classes? See, either yes or no, either true or false.
Yes.
So we call binary classification. We also have greater than 2 classification processes that we call multi-class classification, like whether the thing is bottle or the cat or the pen or the mobile or the laptop or the sun or the fan, means multiple classes. So we call such problem to be multi-class classification. Like when you go
Mr.
to
Deepak, Mr. Deepak, I have one more question.
yes,
Maybe
please
it
ask,
is
please
funny,
ask,
but
please ask.
yeah, this equation of the Z, which is beta naught plus beta 1 x1 beta 2 x2. Consider now x1 is the 1. So our answer will come 1 plus beta 1. So beta 1 value from where we are taking?
Yeah. To that, I have not yet arrived, Saiji. Your answer is, your question is very valid. See, why we are doing it, first of all. In the linear regression, if you remember, in the linear regression, we were finding the best fit line that was separating the points, yes or no?
Yes, yes.
And in this best fit line, if I write the values of this best fit line, it is given as beta naught plus beta 1 x1 plus beta 2 x2.
Okay.
Whereby beta naught was the point where the line was hitting the y-axis.
Yes.
And beta 1 and beta 2 were the points which were trained. They are called trainable parameters. Trainable parameters. Although beta naught is also a trainable parameter. If you remember, you found while doing a linear regression coefficient underscore, and you found intercept underscore. Remember?
Yes.
So this intercept and coefficient, the values of these intercept and coefficient was calculated after training the model. When you trained your model to a data set, after training the model, the best values of beta naught, beta 1 and other betas were calculated, and you found the coefficient and intercept using that command. So what is getting trained? These values, these intercepts, these coefficients, they are getting trained, sir. Nothing else is getting trained. Why? Because see here, your y is equal to beta naught plus beta 1 x1 plus beta 2 x2. These x2 and x1 was already there in the data set.
Yes,
your features, what to train here? The only training was these values, beta 1, beta 2 and beta naught, such that the best line appears to separate the boundary, or the best boundary comes to separate the data set.
Okay, yes, correct.
Here also in a logistic regression, we are creating the boundary. See here, we are creating the boundary such that the best points, the points are best categorized. The points are best categorized. Fine.
Yes, okay.
There might be certain false negatives. There might be certain false negative which must lie here. But this is a boundary which is just separating whether this is one class and this is the second class. Second class. And here, what do I mean by class is, it could be object, it could be noun, it could be category. Like if you go to Flipkart, Amazon, Alibaba sales, you can see electronics. What do you want to purchase? Electronics or kitchen items or groceries. Can you see the classes?
Correct.
So similarly, these, when we take two classes at a time, like if I show my model a knife, and if I show my model a mobile, it must be well trained to create a boundary that this object falls under the class kitchen and this object falls under the class electronics.
Okay.
So this is what is the objective of logistic regression. Understood what I am trying to
say yes,
from past 1 hour. So this was the mathematics behind that, and this is what we will try to achieve from it. And there are so many things, like if I say cost function is also there. Can you give me a name? What are the cost function you learned till date? Cost function. In linear regression, LR, linear regression. What were there? Do you remember cost function? I am talking about loss function. Cost function, loss function. Do you remember any name? All of you. I cannot hear anybody voice.
Trying to think.
Yeah,
we all are
Mr. Deepak, really main reason behind this that we are forgetting that we don't have the recording, because we have to listen this recording and then we have to do the practice.
Okay. Sir, if I recall, we call it MSc.
Yes.
MSc, do you remember?
Mean square
error.
Mean square error. Yes.
Error.
Yes.
Similarly, you have MAE, mean absolute error. You have RMSE, root mean square error.
Root mean square error.
You have adjusted R square. You have R square. Likewise, these many errors. So, mind it, sir, these cost function was for linear regression. Now, if I take for logistic regression, log regression, don't consider it logarithmic, it is logistic. Log regression.
Logistic.
Yes. People misinterpret and then they give that credit to the instructor. Okay. Logistic regression. We have, if you have seen, we call it confusion matrix. Have I ever discussed about it? Confusion matrix. I think yes.
Yeah, it's indicates.
First is recall. Then we have precision. We also have accuracy score, normal accuracy. Then we have, say, what could be the F1 score. F1 score. Okay, so these are the evaluation metrics. We call them evaluation metric. These were the evaluators for logistic linear regression. Sorry, these were the evaluators. Means there must be someone to judge whether you are on the correct path or no. Are you doing the error? Are you going to the right path? Is the accuracy good? Is the loss more or no? Should I decrease the loss or no? Fine. So these were the
Yes.
parameters. Similarly, in the logistic regression, these are the parameters which we have to study. And if you remember, we had a confusion matrix like false positives were there, false negatives were there,
Was negative.
true positive, true negative. Remember?
Yes.
So you have to find each one of them here also. Fine. So say suppose if I draw one thing, how the confusion matrix look like is, it's very simple. It's, you can say, like predicted versus actual. Actual means you call your y, predicted you call y hat. And say if you take it as 0 1, again 0 1. Okay, now give me an answer. If your actual is 0 and your prediction is also 0, so is your prediction correct or no?
It's correct.
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 If it is correct, so it is what the correction has come. Means the correction is negative or positive. Means is it predicting a positive number or a negative number?
Positive number.
0 is, do you consider 0 as a positive prediction? Like suppose if
No,
I
sir.
give you an example,
No, no, no.
there was a cat, but your sorry, there was not a cat, and your actual system is also saying it is not a cat, not cat, and your prediction is also saying not cat. So both are predicting correctly, but it was predicting not cat. So we call it negative. So we call cat as a positive prediction and not cat as negative prediction. Negative is necessarily need not to be wrong. Negative means it was not there. So we call it true negative. Fine. Similarly, here, if your actual is 1, prediction is also 1. So we call it truly predicted positive. Fine.
True positive.
Understood these two?
No, both case it is predicting the correct value.
Yes.
So why the one location true negative and second location become is a true positive?
Because sir, in the second time there was a cat and your prediction was also yes, it is a cat. So positive prediction. But
Yes.
in the previous one there was not cat and your model is also predicting not cat. So prediction is correct, but the type of prediction is negative.
Okay.
That is why we call it confusion matrix. The name is confusion matrix, sir. Don't worry, I'll make you such a perfect in this confusion matrix that you will never feel haphazard. Oh my God, what should I do? It is all haywire. Don't worry. I think this much of trust you hold with me.
Yes.
Oh, here predicted is 1 and actual is 0. So what do you say? Is it predicting correct or no?
False.
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 It is predicting
False
false.
negative. False
Okay,
negative.
we'll see whether it is negative or positive, but we will. The prediction is true or false? First answer.
False.
False.
False, but positive.
False. But the prediction is positive, but output is negative. Actual is negative, predicting is positive. So if I call it f of p, what does it, how to read it? We call it falsely predicted positive. Means it was negative, but it is falsely predicted positive. Understood?
Yeah.
ऐसे पढ़ते हैं. How to read it? Read it like falsely predicted positive. Now here,
positive.
Falsely predicted
Negative.
negative. Is there any confusion now?
No, it's okay.
Now read everything along with me. Truly predicted negative. It was negative. It is truly predicting negative. Fine. Truly predicting positive. It was positive. It is predicting positive only. Falsely predicting negative means it was positive. It was positive. Predicting negative.
Negative.
Falsely predicting positive. It was negative but predicting
Negative.
positive.
Predicting positive.
Understood, sir?
Yes, understood.
So let me write it for you. How to read it? It is read at falsely predicting positive. Just read it as written. You will never feel confusion. And just change falsely positive as per the scenario. Fine?
Yes, fine.
Okay. So this is logistic regression in a nutshell. Although logistic regression takes more than 2-3 classes to let you understand all the mathematics. So by the next class, I will directly take you to the code and see this is how the code looks like. Can you see code? Logistic regression. Then we will see the mathematics I've already covered. We will see the code like this: NumPy, Pandas, Matplotlib. This is what we have just discussed, logistic function. Defining the cost function, we will define the cost function again. This is defined as pi, not sigma. Here we multiply, do not add. We call it log loss. So this is very important logistic function. This is also called binary cross entropy. Here, this function is also called binary cross entropy. Don't worry, I'll explain it. So this is how we will learn it. Gradient descent is one of the important parameter to be learned. And by the next class, I'll make you learn each and every aspect of logistic regression. And we will see the, what should I call it, business problem where churn prediction has to be done, whether the customer will retain or it will churn, it will leave the services. Similarly, and then we will do all the codings. Fine. Can you see the coding? We will do all the codings. We will also calculate the confusion matrix. Okay, guys, fine.
Okay.
Is today's class understood?
A bit difficult, but
Yes.
Yes or no?
A bit difficult. It is,
Sorry,
yes,
I was
but
almost not on class actually. I
Okay.
got an office call, so I was busy with that. I'm so sorry. I
No
missed
worries,
everything.
Shanesh. No, Suresh, Shanesh, but in that case, you have to wait for the recording.
Yeah, sure, sir. I'll be waiting for that.
Yeah. So
How can
fine.
you get the recording?
Okay. So I'm not going to take any photos today. I'm not in that mental situation.
Where can you get this recording?
Now Saiji will explain everything. Okay, fine. Goodbye for
Assign-
today.
Goodbye.
I'll again come with the next class in the next Sunday and hope for the best. Thank you.
Thank you.
okay, goodbye.
Okay, sir.
Goodbye.
Thank you,
Okay,
sir.
thank you.
Bye-bye.
Bye, team. Thank you, team.
What had happened actually?
Yes.
What had happened to sir?
Yeah.
You okay?
Saiji.
Yeah. He's just he's close. Someone he's very close relative has passed away last week.
Okay.
Okay.
So that's why he postponed the last classes as well.
Got it. Okay.
Okay.
Okay, boss. Okay.
Okay. See you again.
Thank you. Bye-bye.